Have you ever wondered if it's possible to travel to the nearest galaxy? Technically, yes. In practice, it's almost impossible. Andromeda is 2.5 million light years from Earth. Even traveling at the speed of light, it would take millions of years to get there. With current technology, the journey would take longer than the age of the universe itself, and that already tells us something important. Andromeda is not a star. It's not a nearby planet. It's an entire galaxy, larger than our own. It contains approximately 1 trillion stars, which means it could host trillions of planets, some similar to Earth, some with oceans, atmospheres, and perhaps forms of life. Thinking about that sparks something powerful, because it implies that maybe we are not alone. But Andromeda is 2.5 million light years away. A light year is not a measure of time, it's a measure of distance. It's how far light travels in 1 year, moving at 300,000 kilometers per second, the highest speed that exists in the universe. And even so, light needs 2.5 million years to travel from Andromeda to us. This means that when we observe it, we don't see it as it is today. We see it as it was 2.5 million years ago. The light reaching our eyes right now left there when the first humans on Earth were barely beginning to walk upright. We are seeing the past. The cosmos we observe is an illuminated historical archive. If we send a radio signal toward Andromeda today, the response would arrive in 5 million years. By then, it's likely the human species will have evolved into something unrecognizable. Or simply won't be here anymore. With our current technology, the trip would take billions of years. Even if we imagined a future where we travel at 10% of the speed of light, something very far from possible today, the journey would last 25 million years. To understand that number, the dinosaurs disappeared 66 million years ago. We are talking about timescales that completely exceed human history. This is where the most important limit appears. Einstein's theory of relativity establishes that nothing with mass can reach the speed of light. The faster an object moves, the more energy it needs to keep accelerating. As it approaches the speed of light, the required energy becomes infinite. And infinite energy does not exist in our universe. This isn't a problem of resources or advanced engineering. It's a fundamental limit of reality itself. There are scientific ideas about possible shortcuts, wormholes, warp drives that would allow bending space instead of moving through it. These ideas have a mathematical basis, but they would require forms of energy we don't know exist in sufficient quantities. For now, there's no evidence we can use them. And even if we could bend space, the amount of energy needed to move a small ship would exceed what an entire star produces during its whole lifetime. Even setting aside the speed problem, intergalactic space is not a perfect vacuum. It's filled with particles, cosmic radiation, and microscopic remnants of matter. At speeds close to the speed of light, even a grain of dust could hit with a force comparable to a nuclear explosion. And there is another problem. If a ship traveled at 99% of the speed of light, a phenomenon called time dilation would occur. Time would pass slower for the travelers than for those who stay on Earth. For the crew, decades might go by. On our planet, millions of years would pass. Traveling to Andromeda would be, in that sense, a final farewell to everything we know as home. And yet, there is one fascinating detail. Andromeda is approaching us at around 110 kilometers per second. Within 4 to 5 billion years, it will collide with the Milky Way. It won't be a violent explosion. The stars are so far apart that almost none will collide directly. It will be a slow process, a gravitational dance where both galaxies deform and eventually merge into a new structure some scientists call Milkomeda. It's curious to think that although we cannot go toward Andromeda, Andromeda will come to us. We cannot travel to Andromeda, but we can observe it, study it, and understand it. Our minds have reached where our bodies cannot, and that is a victory we should not underestimate. Not everything that exists is made to be reached. Some things exist to remind us that the universe is larger than our desires, and that there is beauty in the unreachable. And yet we keep looking, because knowing that Andromeda is out there changes how we understand our place in the cosmos.